Hi everyone, my name is Jevan Winarjo from PMI 2022 Universitas Ciputra. So today we're going to analyze the data using Smart PLS and discuss the result. So there are 4 variables, 2 independent variables, such as financial self-efficacy and procrastination, 1 mediation, fintech adoption, and 1 dependent variable, financial well-being. So the structure of this video is we will import the data, draw the model, and we will run the Smart PLS, conduct the outer and the inner model test, and also conclude the result. So first, we need to save the data as CSV and import the data to Smart PLS. Then don't forget to press the new project to run the Smart PLS. And you can see the data in the screen with the mean, median, and others. Secondly, we need to draw the research model. The first one, click the new path model, move the indicator to the drawing path, and then after moving the indicators to the drawing path, rename all the variables, the independent variables, financial self-efficacy, and procrastination. For the mediation, fintech adoption, and the dependent variables, financial well-being. And don't forget to connect all the variables. And last one, the model will look like this. After finishing the model, we can do the command function in Smart PLS. There are 3 things that need to be conducted: PLS algorithm, bootstrapping, and blindfolding. So you need to run the PLS algorithm and go to outer loadings to see if the variables are reliable. If it's less than 0.7, the color will be red. That means it is not reliable. Therefore, we go back to the model and delete the variables that are unreliable. Now we have a new model with a new reliable variable. After the data is reliable, we conduct the bootstrapping. Just use the default settings and press start calculation. As we can see, it is reliable if it is under 0.05. Then we can press the outer loadings and all the p-value is under 0.05. So that means the data is reliable. To check the Chromback alpha and HTMT, we go back to PLS algorithm and go to construct reliability and validity. As you can see, the data is reliable because the data is above 0.7 in Chromback alpha. And the row A should be higher than 0.7 and the AVE should be higher than 0.5. Now we go to discriminant validity. The top row is the square root of AVE, and it will be diagonal. All the top data is the square root of the AVE per variable. Moving on, going to cross-loading, where all the values of loading of the indicator will be highest compared to the other constructs. After cross-loading, we can go to HTMT, where if the data is below 0.9, so that means the data is good. So we go back to the data that was imported, and with the information given to know the descriptive statistics of each latent variables. We can analyze this with SPSS or Microsoft Excel using this data. However, to find for the correlation for each variables, we can find it using latent variables in PLS algorithm. So we don't have to conduct outer model collinearity since our model is refracting model. Next, after doing the outer model collinearity, we need to conduct the inner model test. So the first one, we need to analyze the inner collinearity. Go to PLS algorithm again, go to collinearity statistics, and see directly inner VIF. If the VIF is less than 5, that means there's no multi-collinearity. From the data, all the variable is less than 5, so there are no multi-collinearity issues. Moving on to analyze the direct and indirect effect. So first we go to bootstrapping, and the result will appear. So this is the result of direct effect. So as we can see, the original sample is the coefficient, the sample mean, the standard deviation, t-statistics, and p-value. The relation is significant if the p-value is less than 0.05. As you can see, the data, financial self-efficacy to financial well-being, procrastination to financial well-being, and procrastination to fintech adoption is not significant. Using the Smart PLS, we don't need to test the Sobel tests. We can directly see from the specific indirect effect. As we can see, my data is not significant since my data is above 0.05, so both indirect effect is not significant. Since my direct effect is significant and my indirect is not significant, therefore, there is no mediation occurring towards this model. So the next is coefficient of determination, which is r squared. So first, we go back to PLS algorithm, and then the data is shown that the r squared is 25.7%. So that means it can explain by financial self-efficacy and procrastination. However, 24.3% is explained by financial self-efficacy, procrastination, and fintech adoption. So, how can we find f squared? So just stick to PLS algorithm and click f squared. Based on the data that we can see, there's a variable that is less than 0.02. Therefore, it has no effect. And the other is small effect since it is in the range of 0.02 until 0.1499. And the last one is the q square. So for the q square, we need to go back to drawing path and press calculate and press blindfolding. The result will be provided for each indigenous variable. So in my data, the variable has small effect since it is in the range of 0.00 until 0.2499. So the conclusion is financial self-efficacy to fintech adoption and fintech adoption to financial well-being is significant. Meanwhile, financial self-efficacy to financial well-being, procrastination to financial well-being, and procrastination to fintech adoption is not significant. That is it for this video. See you next time!